Hey everyone, welcome back. In this video, I wanted to go through the chain rule in more depth, as this is one of the rules that most of my students get really confused on. Okay, so to recap my previous video, the chain rule is used to differentiate composite functions. So let's start with that. What is a composite function? A composite function is just a function within another function. So you can see an example here. We have this x squared plus 1 that is inside this outer function of sine. So these are very common with trig functions because it's always sine of x, right? So it's really common, instead of having an x here, to have some other function. That's a very common example, but really it could be anything. You could really have like x to the fifth to the third, right? Of course, you could use your exponent rules and you could evaluate this in a different way, and you would probably want to do that. But just as a simple illustration, you can see here, I technically have a function within another function. Okay, so now let's go back to the chain rule. The formal chain rule definition is here. So we're going to go through this first, and then I'm going to show you how to do this more quickly once you get more comfortable with the chain rule. So first things first, I want to identify what the inner function is. As a hint, usually that function is going to be in parentheses. Not always, but usually it is. So here, I'm going to identify this part, this x squared plus 1, as u, and I'm going to let that equal u. Then I'm going to identify my outer function as sine of u, because again, I'm rewriting this as u, which you'll see here. So y equals sine of u. Now I'm going to take the derivative of each of these. So the derivative of sine is just cosine. So sine of u becomes cosine of u, and then now this is dy du. Why? Well, because we would say that this is y in terms of u. So because this variable is here, we say y is in terms of u, and that creates dy du. Now over here, I'm going to take the derivative of u. Here, u, we would say, is in terms of x, because x is, I guess you could just think of it as being on the other side of the equal sign. So when I take the derivative of u, I'm now going to get du dx. Now, when I take the derivative of x squared, I get 2x. The derivative of 1 is 0, so it's just 2x. Now we can simply take all of this and we can plug this into the formal definition up here, or the formal equation, I could say. So dy dx equals dy du, which is here, so that's cosine of u, times du dx. I could have plugged in at this step, I didn't. I just left it as du dx, but of course you could just plug in there. And then now just rewriting, so now we're going to rewrite u as x squared plus 1, and then I'm plugging in for du dx, I'm plugging in 2x. So now let me show you an example, a similar example, but where I go a little bit quicker just with my steps. So let's say, as another example, let's say we had y equals cosine of, let's just say 3x minus 5. Okay, so once I get more comfortable with the chain rule, all I'm going to do is I'm going to take the derivative of my outer function. So the derivative of cosine is negative sine. I'm going to rewrite my inner function, and then I'm just going to multiply it by the derivative of the inside. So the derivative of 3x minus 5 is just 3. So then I'm going to rewrite my answer. I'm just going to use my y prime notation here. So y prime equals negative 3 sine of 3x minus 5. So again, I'm just differentiating my outer function and then multiplying it by the derivative of the inner function. All right, thanks for watching. See you in the next video.